Let's talk about the relationship between three different interest rates associated with the bond. The first is the coupon rate. This is the rate that you're going to be paid as a function of par value. The second is yield to maturity, what you'll earn from holding the bond over the life of the bond. And that's going to be a function of what you pay for the bond relative to what you earn from holding the bond, the coupon payments compared to the price. And then finally, this is going to include any sort of capital gain or capital loss. If I pay less than 100 and I get 100 at the end, I have a capital gain. And if I pay more than 100 and get 100 at the end, I'm going to have a capital loss. The other thing that we're going to talk about is the current yield. And what we're going to try to do is relate these three to each other. So remember, the rule is that bonds are issued at or close to par. The mechanism that causes this is either a direct or indirect auction, where you go to potential investors and say, how much do you need to earn from holding the bond? If investors say, I need to earn 5%, the bond is issued with a 5% coupon. If investors say, no, I need to earn 6%, the bond is issued with a 6% coupon. The coupon is set at such a rate that is close to what people want to earn, and so the bond is issued at or close to par. But as time passes and the required yield from holding the bond changes, and it can change for sort of two main reasons. Remember, there's three components in the yield to maturity. The first is the pure time value of money. And it just might be the case that people need to earn more from holding this bond. And so if the yield to maturity gets higher because people need to earn more from holding this bond, then the yield to maturity goes up and the price will go down. The second reason that that the yield to maturity might change on a bond is that the credit for this particular issuer might change. The issuer might become more of a credit risk, in which case people need to earn more from this bond because they're less likely to get their cash flows in the future. Or the credit might get better for this particular issuer. So as the required yield changes, either due to time value of money or a change in the change in the credit, the yield to maturity changes. The liquidity is likely not going to change. The market in which the bond trades and the structure of that market determines liquidity, and that is not likely to change over the life of the bond. So as the required yield changes, either due to changes in time value of money or credit risk, the cash flows don't change, but the price does. So we're going to define this current yield as the annual coupon dollars divided by the price. And so if it's a 6% bond, I'm going to get paid $30 every 6 months. On a $100 bond, I'm going to get $3 every 6 months. Divide that by whatever I pay for the bond, and that's going to give me the current yield. The capital gain is going to be the face divided by the price minus 1. That's going to be the percent change. If I pay 95 and get 100, then it's 100 divided by 95. If I pay 105 and get 100, it's going to be 105 divided by 100. And the yield to maturity is going to be the discount rate, which equates the price to the cash flows, and we're going to double that. And so the yield to maturity is the time and dollar weighted average of the current yield and the capital gain. So we're going to go to a spreadsheet. We're going to look at the current yield. We're going to look at the capital gain. We're going to look at the yield to maturity, and we're going to see how these three things all relate to each other. So here's the spreadsheet we were looking at before, where I have the price using PV here and the yield to maturity using rate. Here I have price using price and yield to maturity using yield. The second tab is just the built versions of this. And the third tab, I've added some more rows. And so let's take a look at the rows that I've added in this third tab. And so we're going to look at these yield calculations. So for a 10-year bond that pays a 4% coupon, if the bond is priced at par, then the yield to maturity is 4%. The current yield, and remember the current yield is going to equal the coupons times the price. That's going to be $4. I'm going to take that, I'm going to divide that by what I'm paying for the bond, which is the price, and that's going to equal 4%. If the price goes up, I still get $4, the current yield gets lower. So if the price goes up to 105, for example, if the price goes up to 105, then I am getting, whoops, I screwed that up. That should be the coupon times par. If the price goes up, the coupons have not changed, but the price is higher, and so note that the current yield is lower. If the price goes down to say 95, the current yield goes up to 421. So remember, the current yield is the coupon dollars that I receive, and that never changes, divided by the price that I am willing to pay for the bond. So here at $104.19, the yield to maturity is 3.5. The current yield is greater than the yield to maturity. I'm actually getting less than 4%. I'm getting 384. But note that I have a capital loss at the end of 4.02%. Well, essentially, I'm going to pay 104, but I'm only going to get 100 at the end. Now, why is that? Because I'm willing to earn less than the bond pays. The bond pays 4. I'm willing to earn 3.5. Why? Well, one of two reasons. Either all rates have gone down, or somehow this bond's credit has improved. What if it is the other way? Now I have a coupon of 4%. I'm going to pay 96, so my yield to maturity is 4.5. My current yield is 4.17, and I'm going to get a capital gain of 4.16. I'm going to get a capital gain between the 100 I receive at the end of the 96, and since I'm earning $4 not on 100, but $4 on 96, my current yield is actually higher than the 4%. And so the point is that here the yield to maturity is 3.5. The way I earn 3.5 is I earn 384 every year, which is the $2 on the 105, and at the end I lose 4%. Essentially, it's not quite an average of these, but it's kind of like an average of these two, is the 3.5. And here I'm going to earn 4.17 every year, which is earning $4 not on 100 in terms of coupons, but $4 on 96. And at the end, I get a capital gain of 4.16 because I get paid 100 and only paid 96 for the bond. And so together, these two give me the 4.5% yield to maturity. Just to bring this in, this is a table of bond prices that are listed in the textbook. And so this is what we were just looking at in the spreadsheet. I was using this bond as well. This is as of January 3rd, 2019. You can see the highlighted bond matures on August 15th of 2029. It has a 6th and 8th coupon. The ask price is $132,789.91. This is the price that someone will buy the bond from you. This is the price you have to pay to buy the bond from them. And then this is the ask yield to maturity of 2.575. And just so going very quickly back to that spreadsheet. So here I have calculated the yield to maturity for the bond from the textbook example. The settle date was January 3rd, 2019. The maturity date is August 15th, 2029. Here is the coupon rate. Here is the price. This is the redemption, the frequency, and the basis, and I get a yield to maturity of 2.575. Note that the price is very high, and so even though it pays a 6.125% coupon, the current yield is significantly lower than that, and I'm going to take a big hit in terms of capital gain. I'm going to pay 132, but I'm only going to get 100, so I'm going to take a 24.5% hit when I buy the bond, and so the yield to maturity is the 2.575. And so this bond originally was paying 6.125, now it's paying 2.575, and the way that happens is I pay dramatically more than par for that. Note here, when I calculate the price as a function of the yield to maturity, I'm off a little bit, and that is because I'm rounding the yield to maturity. If I don't round the yield to maturity, if I just sort of reference this cell, then because this number has greater precision, I get that same number again, that 132.7891. And so again, the example from the textbook, I can't do using the PV and rate functions because I do not have an integer number of periods. So let's just reiterate this just to make sure we understand the relationship between the yield to maturity and the price. remember that the coupon rate and the par value, those cannot change. And so the coupon rate is a fixed percentage and the par value is a fixed number of dollars. But the yield to maturity and the price do change and they move in opposite directions. So if it is the case that the yield to maturity has increased because people want to earn more from holding the bond, either because all rates have gone up and time value of money has gone up, or because of some credit issue associated with this particular bond, then the price goes down. This is the variable dollars, this is the variable rate. And so people earn more from a fixed income instrument by paying less for it. If it's the case that people are willing to earn less because the time value of money has decreased, or because the credit for this particular issue has improved, then people are willing to pay more from holding it. And so again, the coupon rate and the par, these are the fixed percentages and the fixed dollars, they don't change, but the yield to maturity is variable and the price is variable.